Hi guys, my name is Vaishnavi and today we'll be looking at climatology as a subject towards preparation for GATE exam. We're going to have a small introductory session on what the subject has, what are the different subtopics we'll be covering in it, and even looking at a question that may appear or that has appeared in previous GATE exams, so we'll know what we are preparing towards. So firstly, let's talk about the importance of this exam in GATE. We know that GATE has a common part as well as the architecture or planning part. Planning or architecture. Climatology has been asked in both the common as well as the architecture part. So everybody who's appearing for the GATE exam should be able to answer these questions. Let's look at the type of questions that they have asked before. Usually, in the common part, the questions that have been asked have mainly been theoretical. In architecture, there have also been many questions that are theoretical as well as numerical. So you have both MCQs, MSQs, as well as numerical type questions. MCQs are those questions which have one right answer and the rest of it are wrong, which means there is negative marking if you choose anything but the right answer. Whereas MSQs are those questions which have more than one correct answer, which means that there can be 2 or 3 correct answers, or sometimes even 4. And MSQs usually do not have any negative marking. Same goes with numerical. There is no negative marking here. In fact, here you just have to be entering a certain numerical value within a fixed decimal range. So, what weightage does climatology have in the GATE exam? According to the past 5-6 years, it has increased from 4 to 5 to 7 marks average. GATE 21 had 7 marks, where GATE 22 had 4 marks for the subject. So it's quite a hefty amount of marks that you can easily score. Let's look at a question that has appeared before in GATE 2015. This was a numerical mark question that was for 2 marks. Let's read the question first. It says, if a roof is treated with a layer of thermal insulation material, the internal heat gain is reduced by 60%. The U value of the roof slab without thermal insulation is 3 watt-meter square per degree centigrade. Assuming a constant temperature difference between indoor and outdoor, the U value of the thermal insulation layer in watt-meter square per degree centigrade is dash. So firstly, the question looks quite threatening with a lot of scary, words like thermal insulation material or internal heat gain and U value, which I'm sure many of us don't know what it is, and even the units and the quantities look quite scary. But I assure you, this is a question we'll all be able to solve very easily and quite fast by the end of learning this topic. I just gave you this question here, so you know what kind of questions we'll be answering and what we'll be learning and how it is applicable to the GATE exam. Let's come back to this question later and go forward and see as to what we know. What do we know and what we learned in probably climatology classes during architecture or whatever, 6th standard physics or geography is that we know that the earth revolves around the sun, right? So you have the seasons or rotational axes. The earth has a 23-degree tilt in its axis. All of these things. This is basic general knowledge. We also know that, so we might have had courtyards in our design, right? You have courtyards saying, oh, I'm going to give nice cross ventilation in my courtyard, or I have cross ventilation in my courtyard, or I have sun shading devices in my design, right? So we would have all seen or heard of these examples. And we also know that there are climatic zones in India. There are different climates that are there throughout the country, and whether if it's hot and dry, or hot and humid, cold to composite. For example, Delhi is a composite climate. So these are all general basic understanding that we already have from climatology with respect to climatology. What GATE wants is one step further. For example, if you say I am going to provide a shading device for my window, right? GATE wants to know, or we will learn to find out how much exactly is this projection going to be, or what is the amount of heat entering through this window, or what is the amount of heat entering through this wall, and we're going to quantify all of this. There are going to be formula. It's going to show you how heat transfer happens, how ventilation happens, etc. So we're going to be learning all of this. Well, the first topic we'll be starting off with in climatology is the basics again with climate and design. We're going to learn what all climatic factors are going to affect us. For example, air, sun, wind movement, humidity, etc. Then we're going to see climatic zones of India again. Like I said, if there is something, or if you don't remember the basics, we're going to be brushing up all of it and starting from scratch. So there will be a revision of some topics for you. There's also going to be introduction of some new topics. Climate responsive design again has different strategies or designs that are suitable for each of the climatic zones that we learn here. For example, the courtyards that we see may be suitable for some climates, but smaller window openings and etc. will be suitable for different climates, right? So we're going to learn how all of those factors are going to be playing a role in our design, which is what leads us to solar architecture. Solar architecture, we all have our favorite sun path diagram, right? So you have a huge compass-like thing here with different circles and different angles and a lot of numbers. We're going to brush up on how to read a sun path diagram and what to do with the sun path diagram. The sun path diagram actually gives us shadow angles or shading angles for windows, right? If you have a chhaja and a window, we're going to be discussing how say the depth of the chhaja should be based on where your window is, the direction of your window, as well as which part or which latitude your building is in. Next, we're going to learn about principles of thermal design. So when we say thermal design, it basically has to do with heat. So like I said earlier, it's going to talk about heat transfers in buildings, right? So this is a quite important subject because this is where most of the numerical questions have come from. It has some formulae that we need to understand, as well as some terms. For example, there was a question in the previous GATE question where they had asked the units of one thermal quantity, which is U value, I think. And the answer straight away just had 4 options with different units measured, right? So it is a little bit confusing at first, but we're going to take it slow and understand not only the formula, but also how to remember the principle behind it. So if you just remember how it happens, how the concept behind these heat transfers is, you'll also remember the formulae as well as the units. So you can solve such questions easily and quite quickly. Thermal quantities refers to nothing but different measurements that we're going to have while doing these heat transfers. For example, U value was one thermal quantity which we saw earlier in that example question. We're going to talk about simple things like even temperature and heat, energy, just a basic brush up of all of these quantities and learn how they affect heat transfer in buildings. Lastly, we're going to talk about thermal comfort. So we talked about how heat transfers, etc. happen in the building. Now we're going to talk about how it affects humans because we are the occupants or we're the users. So it's going to talk about comfort indices. So indices basically is a fancy word for saying measurement or parameter. We're going to see how these comfort levels are measured, or how we can read these comfort measurements and see what is comfortable and what isn't. So for reading, we have certain tools that help us, like these charts, psychrometric charts. You might have already studied them in your climatology class, but we're going to again understand what is a psychrometric chart and what are the values inside a psychrometric chart and how to read them. There are also other charts like the bioclimatic chart, etc., that are also going to be covered in this topic. So now let's go back to the question that we saw here, right? So if we try to break this down, and just keeping in mind just the topics that I have discussed with you, we can see that this needs only three things. Firstly, you know that there is this word thermal insulation, which means that it's talking about a material or a material property which is causing internal heat gain, right? And lastly, you need to know this U value. So what it basically is trying to say is that there is a material, and if you understand the properties of this material and have this quantity of U value, you have a formula to calculate well how the U value is being affected, because it's getting reduced by 60%. So, and the units that we see here is actually of U value, watt meter square per degree centigrade. So this question is not at all scary, and if we simply understand the concept behind what the U value is, and like I said, the formula and the units, we'll be able to solve this quite easily. So that's it for today's introduction towards climatology. I hope to have an interactive session, and good luck.